Hello, this is Lorraine Jamison, and this is the GoReact quiz number 16, the final one. So in A, you were supposed to solve this problem for the radius of convergence at x equals 0 and then x equals -1. So the problem was x squared minus 2x plus 10, y double prime plus x y prime minus 4y is equal to 0. So with this first one, you substitute 0 into that first equation. And you can't solve this by factoring, so you have to use the quadratic formula. And once you use the quadratic formula, you find 1 plus or minus 3i. So using this, you can graph that to find the radius. And so the distance between the origin and 1, 3 is just the square root of 1 squared plus 3 squared, which is equal to the square root of 10. And for the sake of it, I just included the interval of convergence, which would be -10 is less than x is less than 10, and then you would have to test the endpoints. For B, you know that it starts at -1 now instead of 0, 0. So all you have to do is just redefine your distances as 2 and 3. So you have the square root of 2 squared plus 3 squared is equal to this hypotenuse and then this hypotenuse too. And that's just the square root of 4 plus 9, and that's equal to the square root of 13, which is the radius. So the interval is negative square root 13 is less than x is less than 13. And once again, you would have to test the endpoints on that to make sure that, or to find if they're inclusive or exclusive. So for number 2, you were supposed to find two power series as separate solutions for this equation. Y double prime plus x squared, y prime plus xy is equal to 0. So in order to do this, you use that y double prime is equal to the sum of n equals 2 of cn n minus 1 x n minus 2. And then the second one, you just multiply x squared by the power representation of y prime, and then x by the power representation of y. Because because the x's are to different degrees, you have to get them to the same degree before you can change the indexes. So in order to do that, I just changed the indexes such that they would equal the same index. Or I changed the indexes on the bottom such that x was equal to the same degree in each. So in order to do that, you had to find n of 2 and n of 3 and add it on. Along with on this one, you had to find n of 0. So you have your C0 value here, and then your C2 and C3 values here. And then once you do that, once x is to the same degree in each, so it would be x to the 2. What you can do then is then you can change this index at the bottom here so that it's all equal so that you can add them all together. So you have 2c2 plus 6c3x plus n equals 0, and then you have to change this up here. So c n plus 4, n plus 4, n plus 3, x to the n plus 2. N equals 0, so c n plus 1, n plus 1, x to the n plus 2, and then c n plus 1, x to the n plus 2 plus c naught x. And so now that all of the indexes are the same and the x's are at the same multiplicity, you can add this entire equation together to get c naught x plus 2c2 plus 6c3x plus the summation of starting at 0 of cn plus 4, n plus 4, n plus 3 plus cn plus 1, n plus 1 plus cn plus 1, x to the n plus 2 is equal to 0. So because of this, in order to make this statement true, C0, C2, and C3 all have to be equal to 0. And then you can solve for Cn plus 4. So out here I factored and simplified, so Cn plus 4 times n plus 4, n plus 3 is equal to negative Cn plus 1, n plus 2, and then Cn plus 4 is equal to negative Cn plus 1, n plus 2, n plus over n plus 4 n plus 3. So here's where I got a little shaky, and hopefully we'll get partial credit because I know for a fact my answer is not correct. So here's the cn plus 4. And then I substituted in n values such that I could see the pattern. Gonna be honest here, the pattern was not that clear to me, but we know that C2 and C3 are equal to 0. So anything with a C2 or C2 in it or C3 in it also has to be equal to 0. And that then goes for C5 and C6. So C5, C6, these are equal to 0. C7, C8 equal to 0. Or C8, C9, sorry, equal to 0. And then you're just left with these boxed equations, not this one, not C6, but C4, C7, C10, C13. And if I did this right, what you're supposed to do after that is you just plug it into the y equals equation. And then what you have to do is you have to see the pattern within it. So yeah, yeah. So um, I think I must have done something wrong, but I'm not sure what, because there should be two separate distinct patterns, but I could only see one, and that was C4 times the quantity of the summation of n of 0 of negative x to the 4n, n plus 2 over n plus 4, n plus 3. So, thank you.